last, our last set of speakers up. So here we have a trio from my team. Actually, I didn't introduce myself at the beginning of this session, but I'm Rupert Chaplin. I'm Assistant Director for Data Science at NHS England, and I'm welcoming here Lily, Alice and Matt, who are going to be talking to us about a project they've been leading in our team at NHS England, and this is about accelerating NHS feedback moderation at nhs.uk using natural language processing. So Lily,
thank you for the introduction, and maybe a bit more about the team. We're coming from NHS England. It's a group of about 40 data scientists doing all sorts of work. Many of our colleagues are going to be presenting their work as well. We're going to show you some ads at the end, so you can join them on these talks. So before I begin, can I get a raise of hands if you have written a review online for your NHS services, GPs, opticians? Cool. And for those of you who have done it, have you done it through the nhs.uk website? Okay, thank you very much. So that's a nice headway to the introduction of what the team we did this product for does. So they are the ratings and review team on nhs.uk. What they do is they enable you to go and write reviews about your experiences of the providers, and everything begins with a patient having an experience. Then they go and write a review online about the experience they had, but not everything that is written is published. It needs to be subject to revision to a certain policy, content policy of what people can write. So there was a group of human moderators who, if you didn't satisfy the policy, it would be rejected. You will get an email saying, oh, maybe you are including profanity words or something of the sort. I'm going to talk about what the policy is about in a second. Or it could be approved and it gets published for everyone to see. The providers receiving your review will get notified. And there is a third scenario where your review can be escalated for further review if there isn't a clarity. So the users for these are various. The principal are the providers themselves, because they can get some insight on how to improve their services. The patients, because, well, we all need to know beforehand how a certain provider is doing before maybe enrolling or registering with them. And we had several problems in the team. So one is that for the people that were not compliant with this moderation policy, 9 out of 10 were not resubmitting. And maybe that relates to the second problem that we had, that people would go on a Monday, write a review, and they had to wait until this human was reviewing and giving a response. And they didn't bother going back and rewriting, omitting their faults on the review. Also, it was quite expensive, as you can imagine, and it was not possible to scale up because the team had a certain size, and maybe one of the reasons few of you knew about this service or haven't used it is because you didn't know it existed, but they cannot publicize it because they couldn't have the capacity to review what you were writing. So, as data scientists, what we did was to create something, a tool that could do that moderation of the reviews automatically to reduce the burden on the human moderators. And we did this as a part of a multidisciplinary team working with developers, testers, people doing user research, designers on what response the people will get when they went onto the page. And we ended up with the similar pathway, but instead of having this expensive outsourced third party that was doing the moderator, now we have an automated moderation tool. The moderation policy is what you would expect from ML. We don't want people writing profanities, maybe all caps, links, emails, identifying people, describing. We want them to describe their experiences, not just to give general description. Oh, it was great, because that's not adding any insightful information, neither for the patients, not for the providers. And then we had another one about not complaints, not because we don't want complaints, we do want them, but actually they need to follow a different channel, they have a follow-up, and it's traceable, so it needs to go that way. And the last one relates with the presentation we just had, which is we don't want people writing about suicidal ideation or self-harm because it can be triggering for other users out there. So we did on that. The type of responses that they will get is immediately as they go to the page and they type something, they will get some response on, you did this, please do remove. If we're not sure, we have this software option of it looks like you are, so they are given the option to maybe say, no, I disagree with what you're saying, and then it gets sent to the second line of expert human moderators, or simply we send them to the right channel. Now, Matt here is going to describe how we build each of those records.
Thank you. Yeah, so I'll talk through some of the methods we did. So these are the rules again here. So I'll start with the simplest rules on the left. So these are the ones that are checking for inappropriate language, URLs, email addresses, and fully capitalized text. So as you'd expect for inappropriate language, we just have a big list of words that we don't allow, and it's just a case of seeing if those words in someone's review are on that list. For URLs and email addresses, we use a combination of spacey and some regex matching to find patterns in the review. And then for fully capitalized text, again, very simple, just counting how many all caps words there are and asking is that above a defined threshold that we have. On to some of the slightly more interesting ones. So for the names rule, this is the rule that's detecting when someone's left someone's name in a review. We use a named entity recognition model. And specifically, we use a BERT NER model, and this is capable of identifying different entities in text. So you can see on this example here, this isn't a review, but just an example text. It's picked up things like dates, a person, organizations, etc. And yeah, as you'd expect for the names rule, we're looking for entities that are labeled as a person. So we pass the review through the model, it spits that back this list of entities, we filter just on the people, and then we're able to do a bit of post-processing on that list of names to try and reduce some of the false positive cases that we have. So, for example, disease names are often picked up by mistake by the model. Sometimes they're named after people. And also, when people talk about, mention the organization name in their review, like, for example, Guy's in St. Thomas's Hospital, it's named after a person, it has people's names in, and the model can sometimes pick up on that by mistake. So we have some steps to reduce some of those false positives. And we also have some other rules as well to allow people to sign up a review with their own name and things like that. These three rules, so the not an experience rule, the complaints rule, and the safeguarding rule, these are all models that we trained ourselves, and they all follow a similar approach. We have an embeddings model or a vectorizer, and then a classification model on top. So for each of these rules, we tried lots of different combinations of different embeddings models and classification models. But for example, the not an experience rule, we actually found that a simpler approach of using just a bag of words vectorizer and then a logistic regression classifier on top gave better performance. So that's what we went with for that rule. For the complaints rule, we did go with an embeddings model. So we use an MPNet embeddings model, and that transforms the text into a numerical representation that you can map into a vector space, and then we have an SVM classifier that basically divides that space the best it can into classifying stuff as either not a complaint or a complaint, and then we can give the response to the user. For the safeguarding model, we use a BERT model again, and that serves as both the embeddings part of the model and the classification model, and then we were able to fine-tune that on our own data to classify things as either safeguarding or not safeguarding. And then we have, for that rule in particular, right now we have a three-way classification, so it's classified into low risk, medium risk, or high risk, and we can give the appropriate response to the user. And with that, I'm going to pass over to Alice to talk through some of the data.
Thank you. So, as Matt mentioned there, some of these models take training using our own specific data, and we also had to validate all of the models using data to check they'd work well. So this meant that we had to get data. Fortunately for us, the ratings and reviews team actually hold on to all of the reviews for 2 years after they're submitted. So we had a really rich data set there with data sets marked either as published or with a rejection reason that we could use. However, for some rules, particularly safeguarding, fortunately, there's not many examples of people that write reviews containing this kind of sensitive content. So we had to find ways to get more data. So to start with, we just augmented existing data. So we took real existing examples of safeguarding reviews, and we did 2 things. We just swapped the sentence order, and we also swapped words out for other words that had similar embeddings values. This worked really well and improved the performance, but we wondered if we could get more data. So we also experimented with just generating completely new data. So this was actually a sort of discovery spike where we were trying to see if we could make use of this new LLM technology to improve the work on this project. So we actually tried querying the OpenAI like GPT-4 endpoints and just asking it to please create us an example of a safeguarding review. This involved engineering the prompt really carefully to make sure that we were defining exactly what a safeguarding review is. And we also had to check the outputs really carefully to make sure that they looked like real reviews. For both of these steps, we worked really closely with the internal moderation team to make sure that we were doing these steps right. Unfortunately for us, we actually didn't find that this data enriched the performance. We also did a little bit of a look at whether we could just use the LLM similar to the presentation before, and just whether we could ask it the question of, does this review have safeguarding content in it? But we did come across quite a lot of problems in sort of trying to jailbreak it. It really didn't like reading big reviews full of this kind of content. It would often just say, I'm sorry you're feeling this way. So it was quite difficult for us to get those prompt engineering done really reliably. So to evaluate the different models, we used some key performance metrics, just things like accuracy, precision, recall, F1 scores. When it came to the evaluation, we made sure to only use real data, so none of the augmented data, with the exception of safeguarding, just because that data set was so small. And as Matt mentioned, we tried various different combinations of different embeddings models and different classifiers to see which model won out. When we were judging which model was best, for different rules we had different priorities, so we were maybe sometimes more interested in minimizing false positives, and sometimes we were more interested in minimizing false negatives. So for example, taking the safeguarding rule again, if we miss a safeguarding review, so someone writes this kind of content and we publish it, this is a real problem. As Lily said, it's triggering to people who might read it, but also we've missed a chance there to reach out to that person and signpost them to help. However, if someone writes a review that doesn't have this content in and we mistakenly sort of say, oh, we think that you're writing this kind of stuff, it's a bit embarrassing, maybe a little bit of reputational damage, maybe it's not a great thing for people to read, but it's not quite such a big problem. For the safeguarding model as well, we had to get it through clinical sign-off. So because it's obviously dealing with really sensitive topics, and because it's involved in like a signposting process, the clinicians wanted to make sure that we were capturing as many safeguarding reviews as possible. So they helped advise us on the kind of acceptable metrics, and we had to present our model and discuss it with them and get them to sign it off before they were happy for it to go live. So this was the overall performance on our validation data for the the more complex rules that we mentioned. As you can see, the metrics vary, but overall, the product owner was actually really happy with this. You've got to remember that actually the external moderators, they're humans, they make mistakes too, and actually they weren't. They did make quite a few mistakes, so this performance was actually really great. Once we were happy with the models, we deployed them to sort of an endpoint per rule. Then what happens is when someone submits a review on the NHS UK website, this review gets sent to a Flask app, which is hosted in Azure DevOps. This then sends the review out, queries each of those endpoints to find out which of the rules have been broken. It then feeds this information back to the front end of the website where those screens Lily showed are displayed to the user so they can maybe make changes or we signpost them, etc. So I'm going to hand over to Lily just to sum up what the overall net results were from this project.
Yep. So I can say that we met or solved the problems that we were after with a reduced time from several days to nearly real time for all the moderations, with the exception for safeguarding. That still, because of the sensitivity, is still being reviewed by the human moderators. Decrease operational cost from probably to 1/10 of the cost that we were incurring. And now we can promote more the service, and because scaling up, it's an option for us. What are we doing? The work didn't end up there. As data scientists, probably the most interesting part is building the maths, the algorithm, proving that it works. But on this one, I think the more challenging part was making it live and making sure that everyone in the organization was happy to sign off and leave these. The first AI implementation on NHS.uk went live, and for that we had to go through several groups proving the technology, how reliable it was going to be, how resilient, some bias analysis and comparisons on the implications that something like this could have, analyzing the hazards, taking some safety measures. So what we're doing now is monitoring the activity, ensuring that it's still being in use, that the latency is in the right place, that the compute behind the models are enough to give a response. The performance, of course, to see how many times one rule is being flagged. Also keeping an eye on some issues, especially for the ones that are not model-based, but the deterministics, the one that Matt explained about using patterns and words and capitalizations. So all of that are being recorded for us to come back and try to improve the models that are out there, or the modules, the solutions. So we're working on evaluation, improvement, monitoring, and the fun continues. Some other things we can do is add more rules into the moderations as they are needed, and these can be reused in other places as well, in other services, other applications, not just for NHS England. Our repo is open on the first link. The second link will talk a bit more about how to, well, the project itself, and the third one, you can keep it for the next time you go with an NHS provider. You can leave your review and hopefully improve the services or give some insight. Thank you very much. Before we jump into questions, these are the other talks by my team. Please have a look. And now invite her questions.
Thank you very much, Lily. I like the cross-promotion going on here. Very good. There's a couple of items of kind of praise and coming up in the Q&A, one saying it's their favourite example of a use of kind of LLMs. The other, I guess, kind of acknowledging the challenge that you've overcome in actually getting something to deployment and out live to, well, patients, I suppose. And it was asking you to reflect on what do you think it is that's enabled this project to succeed in getting to that point when so many others fail?
I'm gonna blame it on the leadership. We had a product owner who had the vision to engage the data scientists, and engage different parts of the organization to make it happen. And yes, it was a lot of numbers and presentations and explaining over and over again to different stakeholders what the models were doing, what were the limitations, and also talking about what could happen if we did not implement this.
And I had a question actually, just because at the beginning you highlighted that this was a big kind of multidisciplinary team that you brought together and included a user research kind of element there. I was curious, kind of what did you get from that user research? What was the user view once you had this tool out and deployed? How did they respond to it?
Their view was positive, otherwise we wouldn't be here, so that's also some of the things I should have mentioned at the beginning. They fed back on things like, how long are you willing to wait until you get a response? Is this response clear? Do you prefer it explained as something different? What do you understand from this? What is missing? Is the design of the response what you would expect? Things like that.
Turning the slide though again, there was a question about how in the overall workflow, how the false negatives are handled. So you set out, I think, that you kind of think about the balance of harms between false positives and false negatives. But I guess in any scenario there will be some false negatives still. So how is that handled in the system?
If I understand the question correctly, it was different depending on the rule. For safeguarding, we got the clinician's input on what is best to have. Do we want to bias the model towards missing more responses or towards capturing everything? Because capturing everything might be a trade-off. The human moderators might need to manually review more comments by hand. On the rest of the models, it was a business decision, the product owner as well, deciding what could be the right balance in between, and also comparing against the performance of the moderators, which were not always the more consistent on their responses. So staying at least the same level and a bit more.
There is a small mitigation. There's a small mitigation as well, which is that part of this service is that providers are meant to respond to your comment. So there was quite a big communications around, communicating to the providers that this process had changed and they might see some things slip through, and to, please alert us and we'll get it off the website and we'll add it in for future training and things like that. So it's the best fallback we can have for false negatives in this kind of situation, but at least we've got something.
There's a question Adam raised about the use of LLMs in this development. So you've used LLMs to both kind of generate some data for training on, and I think Adam's suggesting there was also a use of that same model for categorization in some sense. So does that raise any issues? It feels like the dog eating its own tail somehow.
You go.
I was going to say it was two quite separate spikes. So whenever we were sort of experimenting with generating data using LLMs, that was feeding into those kind of embeddings and classifier models that you saw. And then when we were experimenting with instead using an LLM approach for the actual classification, we were using our previous data sets, often just real data sets. And actually in both of those situations, we found that the data augmentation had actually done a better job than the data generation. And we actually found that the LLM performance for the classification didn't actually do any better and had a lot of other cons around reliability, especially with the sort of jailbreaking with the prompts, and cost. Cost was a biggie there. So yeah, we didn't have to get into that difficult space of, I can see your point there, but fortunately we didn't have to navigate that.
And last question I pick up, which I'm not sure if it's just kind of inviting you to use foul language here, but it was about users can be quite inventive in trying to use profanity, even if you kind of impose rules that prevent it. So how did you respond to that? How did you take steps to kind of prevent those kind of false negatives slipping through on the profanity side?
No model can be perfect. The models can let through new words that we use. The language is evolving, and even maybe not just changing numbers with letters to make the word go across, which that's accounted for on the model. But then we fall back on the providers reporting back to us, oh, this is on the page. They notify us, they take it down. So there's still this human involvement and retraining and improving and the monitoring that we were talking about earlier.
There's still humans.
There's still humans. Yeah. We need the humans. Technology won't solve all the problems.
Great. Thank you very much, Steve. Okay, that was our last talk in this session.